Hey guys, today we're talking about section 1.2, classifying numbers. Right? The goal is to be able to classify all real numbers as to what groups or what sets of numbers they belong to, whether they are natural, whole, integers, rational, irrational. They can be more than one. They can belong to more than one group. Our goal is to figure it out, right? So I'll start here with all real numbers fit into one of two categories. Does everybody know what two they are? All real numbers fit into either rational or irrational. All right, now before I go any further, let me talk about real numbers for a second. Every number we use in this class is a real number. There is a set of numbers beyond real numbers. They are called imaginary numbers. You'll learn about those in Math 2, I think, when you get to high school. In this class, we will not use any imaginary numbers. We will only talk about real numbers. And I claim that every real number is either rational or irrational. Let's see the difference. All right, what is a rational number? A rational number is a number that can be written in the form A over B, where A and B are both integers and B is not allowed to be 0. I think that's a little bit of a mathematical definition. I think a simpler way to say it is what I've said here second. Rational numbers are numbers that can be written as a fraction. Right? If a number can be written as a fraction, that's what makes it rational. Maybe in the past you've done something called ratios. That's all a ratio is a fraction, and that's where rational numbers come from. They're numbers that can be written as ratios or fractions. So, as we went over yesterday, there are two types of decimals that can be written as fractions, right? In decimal form, a rational number will either be a terminating decimal or a repeating decimal, right? All terminating decimals can be made into fractions. All repeating decimals can be made into fractions. So all of those types of decimals will be rational numbers. Now, non-terminating, non-repeating decimals, they cannot be written as fractions. So they will not be rational numbers. In fact, they will be irrational numbers. If a number is not rational, then it must be irrational. Right? Those are the only two types of numbers. Well, I shouldn't say that. Every real number is either going to be one of those two types, rational or irrational. Talking about irrational numbers, though, is a little bit harder. And to talk about irrational numbers, we're going to need to do a little bit of review first. Because one place that irrational numbers come from are square roots. So let me talk about square roots for just a minute here. The first thing you need to know about square roots is actually perfect squares. A perfect square is a number that is the square of a whole number. And I will just do one example. For instance, 25, I claim, is a perfect square. It's a perfect square because it is the square of a whole number. 25 is a perfect square because it is equal to the square of 5, or 5 squared. That is what a perfect square is. Take any whole number, square it, and you get what's called a perfect square. Now what about square roots? All right? Square roots. The square root of a number is another number that when multiplied by itself is equal to the original number, right? The square root is some number that when multiplied by itself equals the original number. For instance, the square root of 49 is 7 because 7 times 7 equals 49, right? The square root of 49 is 7 because when you take 7 and multiply it by itself, you get 49. Do you remember the symbol for square root? It's the little division symbol with a little check mark though, kind of, right? All right, square roots are important to know a little bit about because it's one of the places we get irrational numbers. I have this little challenge to see how fast people can name all the perfect squares up to 100. How fast do you think you can do it? They are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Those are the perfect squares in order up to 100. Can you name their square roots? Can you name what number multiplied by itself equals them? Right? That's pretty easy. The square root of 1 is 1. What number multiplied by itself equals 4? Well, 2 does, right? What number multiplied by itself equals 9? That'd be 3, and so on. So these are perfect squares up to 100 and the square root of each one. Taking the square root of a perfect square is really easy, right? What's the square root of 49? It's 7. What's the square root of 81? It's 9. But what's the square root of 10? 10's not a perfect square. What's its square root? Well, the square root of a non-perfect square, that's a little tougher. And it's tougher because you can't really think of a number that multiplied by itself equals 10. The square root of a non-perfect square is a non-terminating, non-repeating decimal. So, as we learned last section, because it's a non-terminating, non-repeating decimal, it cannot be written as a fraction. So it's not a rational number. In fact, there is no exact answer because it's a non-terminating, non-repeating number. And this leads us to irrational numbers, right? Let me go back for a second. A non-terminating, non-repeating decimal cannot be written as a fraction. And if it cannot be written as a fraction, it's not a rational number. And if it's not a rational number, then it's an irrational number. An irrational number is a number that cannot be written as in the form a over b. It's a number that cannot be written as a fraction. That's what an irrational number is, a number that cannot be written as a fraction, or a non-terminating, non-repeating decimal. All right, square roots is one of the places we find irrational numbers. How can you tell if a square root of a whole number is going to be rational or irrational? Well, we've just gone over this. If you're taking the square root of a perfect square, then you will get a rational answer. If you are trying to take the square root of a non-perfect square, you know, like the square root of 10, then the result will be irrational. Right? Perfect squares have square roots that are rational. Non-perfect squares have square roots that are irrational. In general, since an irrational number cannot be written as a fraction, then it's going to be a decimal. You know, if it can't be written as a fraction, it's going to have to stay a decimal. But not just any decimal, right? Since it can't be written as a fraction, it's a certain type of decimal. It's a non-terminating, non-repeating decimal. Okay, so there's three types of these that we'd like to be familiar with. There are three main types of irrational numbers I'd like you to be able to identify. The first one is easy. Most of you know it. It's pi. Right? Pi is an irrational number, probably the most common irrational number. It's a non-terminating, non-repeating decimal. How many digits can you name pi to? 3.14159? Can you keep going? There's more. As we just learned, square roots of non-perfect squares. If you took the square root of a non-perfect square, you would also get a non-terminating, non-repeating decimal. You could try it. Try taking the square root of 10 on your calculator and see what happens. You end up with a non-terminating, non-repeating decimal. It's an irrational number. And last up, patterns that don't repeat. We looked at these last section. That would be like 1.020020002. It's a pattern, but not a repeating pattern, so it's non-terminating and non-repeating. These are the three main types of irrational numbers. So our job right now is, can you tell the difference between rational and irrational numbers? We're going to do examples in part 2. Guys, so we've just gone over the three types of irrational numbers. Let's do some examples. In these examples, we want to say if each number is rational or irrational and why. All right, again, if you want to turn off the video, try on yourself and then turn the video back on. I think that's a good way to do it. The first one, 2.125, that is a rational number. Why is that a rational number? Because it terminates. Terminating decimals can be written as fractions. That's what makes them rational. How about the second one, 2.111 repeating? That one is also rational. That one repeats. Could be written as 2.1 with a bar over it, right? The next one, 2.010110111. That one is irrational. That is one of those patterns that does not repeat, so you could not use a bar over top of it. The fourth one The fourth one is rational. It also repeats. It would be 2.1234 with a bar over it. And the last one, also rational. It also repeats. The 3 repeats, so it'd be 1.083 with a bar over it. Hope you got those. All right, so the difference between rational and irrational, real quickly. Rational numbers can be written as fractions. Irrationals cannot be written as fractions. So when you see a decimal, rational numbers must be terminating or repeating. That's the only kind that can be written as fractions. Irrational numbers are non-terminating, non-repeating, and cannot be written as fractions. However now, numbers that are rational might belong to other groups also. These are groups I'm sure you're familiar with, but we're going to go over them real quickly as a review. We got 3 sets of numbers you can see on the screen. Natural numbers, whole numbers, and integers. Natural numbers are the numbers 1, 2, 3, and so on. The big thing is they do not include the number 0. Whole numbers include all of the natural numbers, but they also include the number 0. The only difference between whole numbers and natural numbers is the number 0. So whole numbers would be 0, 1, 2, 3, and so on. And the last set of numbers we talk about are integers. Integers include all the whole numbers and their opposites. Or you might say they include all the whole numbers and the negatives. So every whole number is an integer, but also the negatives. They go in both directions, all the positives and all the negatives. So if you take a look at a number like the number -2, -2 is just an integer, but it's also a rational number because I could write it as a fraction. You know, it's a terminating decimal. The number 0. 0 is not a natural number, but 0 is a whole number, and it is an integer. And since it's a terminating decimal, it's also a rational number. Remember, every number is either rational or irrational. And numbers that are rational might also belong to some of these groups. And that is going to be most of your job on the homework, is can you determine all of the groups that different numbers belong to? So I wrote, obviously a number can belong to more than one classification. That's a fancy word for groups. Below, we want to identify all the groups that each number belongs to by putting a check in the box of each category. And I put a hint there. You might want to simplify it first. Now, I would encourage you, go ahead and stop the video if you want and try to do it first yourself, and then start the video and see how you did. This is hard for most people to get these exactly right. Let me go over them. The square root of 100, I recognize right away that can be simplified. The square root of 100 is 10. So 10 is a natural number, it's a whole number, it's an integer, it's rational, and of course it's a real number. And why don't I get it out of the way right now? All these numbers are real numbers. Right? Every number we use in this class will be a real number. Maybe what we ought to go through is go through and check which ones are rational and which ones are irrational. Right? Because every number also belongs to one of those two sets. Every number is either rational or irrational. So let's see, which ones of these would be terminating decimals or repeating decimals? Well, this is a terminating decimal, so it's rational. the square root of 20. I typed that into my calculator and I found out that the square root of 20 is 4.7213, and that baby just keeps going. You know, 20 is not a perfect square. So the square root of it is a non-terminating, non-repeating decimal, better known as an irrational number. 12 over 7. Well, 12 over 7 is a fraction. That makes it rational, right? Rational numbers can be written as fractions. Negative 12. That's a terminating decimal. Negative 32 over 8. That is a fraction that can be reduced. It reduces to negative 4. A terminating decimal, therefore rational. 2.3 with a bar over it. 2.3 with a bar over it is a repeating decimal, so it's rational. And the number 13 is a terminating decimal, so it's rational. This whole group only had one irrational number. But our other job is to name what other groups the rationals belong to, right? The irrational number is done. Irrational numbers don't belong to any other groups. But rational numbers do. Let's see, 7.42. Well, you know what? Wait a minute. Here's an interesting thing. All three of these groups involve whole numbers or negative whole numbers. If I don't have a whole number, I'm not going to be in one of those groups. So a decimal is not going to be in one of those groups. A fraction, 12 over 7, that's not a whole number. Not going to be in one of those groups. But negative 12 is, that's a whole number. Well, it's a negative whole number. That makes it an integer. Negative 4 is also an integer, but it's not a whole number and it's not a natural number because those are only positive. A repeating decimal is none of them. And the number 13, that is a natural number, a whole number, and an integer. That is what the chart should look like. I hope you did well. Your homework will have several questions like those on it. Good luck.